Alrighty, I believe I'm recording. This will be day 13th, I believe. I'm pretty sure. Give me 1 second. Let's see. Yeah, day 13. Again, thank you to everyone for the support. Comment if you're watching this video, anything you want, I'll respond. And yeah, it's pretty early in the morning, so I'm doing my YouTube video pretty early and uploading it early, hopefully. Yeah, I got a busy day, so yeah, we'll see what we can do today and for how long. Yeah, so today we're gonna finish this off, and let's see if we can. What is the next thing? Sorting algorithms, I believe. Yeah, sorting algorithms. Dang, can you guys hear my... Okay, give me 1 second. My mic sounds weird. No, okay, we're good. Alright. Okay, so we're gonna go here. So we have a problem to solve. So in LockedIn, we process tons of usernames. They are often structured as lists of lists. For example, a separate list of users for each influencer followers. Okay. So the thing what I don't like about this is they don't give examples. It would be better if they do an example, but it's cool. So a list of lists: George, Eva, George, Diane, George, Eva, Frank. Target name George, expecting 3. Okay, I see how it is. It should iterate all of the names and nested list of lists, count all the instances of target name, then return the count. What's the time cluster of your solution? It should be ON and the number of names, but O of M, if you consider M, if you do consider... okay. Well, there's one way that I can think of. So let's just say total is equal to 0. So for list in list. Damn, this might be an n squared solution what I'm gonna do, but why not learn and continue to do it? So for list and list, so this will get each list. Then we're gonna do for name and list. We're gonna do if name is equal to target name, we will do total is equal to 0. Wait, sorry, total is plus equal 1, and then right here we will return total. Oh, what did I do? For list and oh, sorry, I did not complete that. For list, sorry, list. There you go. Pass, but okay, cool. Alright. That was fast, huh? That's not an n squared solution because there's 2 for loops. Well, let's see how we did it. So total, they have 4 inner list, or list of lists. Okay, for name and inner list. Yeah, sorry. Yeah. Hey, come on. Bar for the solution. So that's a W. Okay, we're doing sorted algorithms now. This looks like a long ass section, man. Dang, so we're gonna learn bubble sort, merge sort, insertion sort, quick sort, fixing quick sort, why quick sort. So damn, this section is pretty important. Let's look at what we're gonna learn in the future. Okay, exponential time, data structures intro. So I guess this is where everything gets a little bit trickier. Stacks, last in, last out, queues. Nice. Red black trees. Don't think I've ever heard of that one. Stack queues, linked list, cool. Alright, yeah, let's go back to what we were doing. We were doing sorting algorithms. Okay, cool. Sorting algorithms. Almost every, I guess no uploaded a video, so let's go see what my boy did 3 minutes ago. 3-minute video, Noah.
Super quick video because I don't know if I'm gonna make it or make enough time to make a video, and I already know how my fucking people say. Welcome to 153. I think I'm gonna make a super fast function. So what do I need?
Yeah, my boy's grinding, man. Crazy. Anyways, sorting algorithms. Almost every action you take in web app relies on sorted data. Just looking up a user's profile in database likely relies. Wait, almost every action you take in a web app relies on sorted data. Just look up a user's profile in a database likely relies on a sorted index, which we'll talk about in another course. Fortunately, most programming languages provide their own standard sorting implementation. In Python, for example, we can use the sorted function items print sorted items 1 through 5. Assignment: we need to sort influencers. So basically, what we learned here is that there's a sorted function that takes in a list and sorts the numbers in order from least to greatest. Okay, so we need to sort influencers by vanity. Complete the vanity and vanity function. Okay, so there's two functions we should mess with. Okay. Vanity and vanity function. The vanity function accepts an instance of an influencer and returns the vanity score. The vanity score should be the number of links. I'm kind of confused. The vanity function. Wait, we sort of complete the vanity and vanity function. So vanity. Oh, okay. So vanity sort vanity. Okay, we're gonna complete those functions. The vanity function accepts an instance of influencer and returns the vanity score. The vanity score should be the number of links in their bio multiplied by 5 plus the narrow number. So the vanity function accepts an instance of plus and returns the vanity score. The vanity score should be a number of links in their bio. So is influencer. So if I run it, vanity, yeah, okay. Let me just see. The thing is, I just like looking at an example of these guys who create these don't put examples. So 10 to okay. So their input 1 times 5 1. So I don't get this. The vanity score should be the number of links. The vanity function should return a list of influencers ordered by their vanity from least to greatest. You can pass a function as a name called key to sort of return. So key is equal to sorted influencers. Return key. Bro, I'm confused. What the fuck is going on, bro? Like, what are you asking me for? Oh, bro, what the hell? So the vanity function accepts an instance of an influencer and returns the vanity score. Instance. Accepts an instance. What the fuck does instance mean? What does instance mean? In Python, an instance refers to a specific object created from a class. Damn, fuck. I guess I'm learning this shit right now. I don't even know. When a class defines an init method, it acts as a constructor for the instance. So def init. So is my camera tripping? Damn. I see like weird stuff coming. So def init self name breed. So self.name equals name. Dog1 name. Dog1 name is Buddy. Dog2 dot name is Lucy. You do dog2 dot breed. It'll be Labrador. Okay. We need to sort influencers by vanity. Complete an instance of an influencer. Okay, so it accepts an instance of an influencer and returns a score. Returns a score. I'm confused. I'm actually very confused, I'm not gonna lie. Please explain this to me slowly so I can understand and try the problem on my own. Code already given. Step by step. What is the problem asking? You're given a list of influencers. You need to calculate a vanity score for each influencer. Sort them from least to most vanity score per one. Bro, I didn't. Look, don't tell the answer. I would like to do it on my own. I'm not looking. Okay. So cool, vanity influencer. This function takes one influencer. You need to use the two of their attributes. One of them is worth more than the other. Do a small math formula with those two numbers. Return the result. So takes an influencer. Takes an influencer. Dog Fuck, bro. I don't get this. Attributes, one of them is more than the other. Do a small math formula. The function takes one influencer. You need to use two of their attributes. This one, so saying, says influencer returns the vanity score. The vanity score should be the number of links. Number of links is here. So if I do return kind of like this, return dog it takes an influencer. What the fuck? Like a name, an instance of returns a vanity score. The number of links multiplied by 5 plus the number of selfies. Oh, so it takes in this. Links in their bio. They only have one link in their bio. So that's I don't understand why it's like I just don't get it. I know that this is right here. So let me understand what's going on here. That's not in it. Is it like that? Yeah, in it. Okay. And then so now I gotta return create instances. So I gotta create an instance. So if I create an instance of x is equal to I gotta call the class name influencer, then I gotta get influencer, and I do influencer, influencer. What does influencer return? This one. The vanity function accepts an instance of an influencer. The vanity square. This is why I skipped the last part. I don't understand how to do this shit. I don't think it's the selfies. Is it the selfies? No, number of links. Num underscore bio links times 5. Now I gotta do plus x underscore something, num underscore. I think I just can just do return here like this, right? Return. I'm gonna need GPT to help this. I guess we don't need to call a class name. You don't need to call influencer again. You're already receiving one, right? You just want to return a number, not an influencer object. The variable x is not defined. Maybe you went if okay. So influencer. Actually, we could just keep that parentheses. It looks nicer. Plus influencer. What? Influencer dot num underscore bio underscore links times 5 plus this. The vanity shows that returns the vanity score. The vanity score should be the number bio multiplied by 5. Okay. So this influencer, what this does, it goes in here. Then it goes. Okay, no, we need influencers. Influencers, the vanity sort function should return a list of influencers. So return a list of influencers. So return a list of influencers ordered by their vanity. So return. You can pass a function as a name parameter called key to sort. You'll be using Python. Yep, I know that. I know I was going to use sorted somewhere. So function, you teaches us how to compare the influencers. Bro, am I just oh, I see how this works. 0, 100. No, you need 101 to the 2. I still don't understand what the fuck is a vanity. They sort this list based on each item's vanity score. So for list in influencers, it's nowhere in the list. We wanna sort that list. You need to pass a function as a name. Doesn't make sense. Function should return to ordered pair. So you wanna It should return a list of influencers ordered by Vanity from least to greatest, right? Yeah, so I gotta get 1, 2, 10, 2, so that one's just, that's right. So that would be... So we get each list. Okay, so let me just sort it. Yeah, it just gets the... Oh, I might be tripping. I don't even need to do this for loop. If it's like that... What about if I just do this? Return influencers. 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 Sorted. Info. You're right, sorry. What if I sorted influencers? What would happen? Order by their value from least to greatest. So it's like 1, 2. I'm confused. Key. This is score sort by, so you just need to tell the sort to use. That's like, you already wrote a function named vanity, right? That gives a score to sort by. Oh, vanity. No. Vanity, 100% is vanity. Has to be. Has to be vanity. Key vanity. Key. Why would I use key equals? I've never seen it in my life, bro. Hey, this problem, bro. Me dead serious with you. I don't understand it. I don't understand this. Yeah, there's no way I would not have solved this. I understood this. I just don't understand this. I don't like that problem at all. Not even a bit, bro. That was the shittiest problem I've solved all day. Made no fucking sense. No sense, man. Alright, Okay, I'll go until here. We'll stop at merge sort, and I'll do that tomorrow. Yeah, I'll do bubble sort. Okay, yeah, I'll learn bubble sort today. Yeah, we'll learn bubble sort today. So, okay, so bubble sort. Wait, if the standard sorted function exists, then why should we learn to write a sorting algorithm from scratch? We choose to write sorting algorithms from scratch not because it's easy, because it is hard. In all seriousness, in this chapter, we're building some of the most famous sorting algorithms from scratch because it's good to understand how they work under the hood. It's great algorithmic thinking practice. It's fun, at least for me. Bubble sort is a very basic sorting algorithm named for the way bubble up to the top of the list.
Bubble sort is the sorting algorithm that everyone learns, but no one actually uses in the real world because it's so slow. We learn it because it's easy to understand, and once we appreciate how slow it is, the other sorting algorithms are just that much more impressive. It all starts with an unsorted list of numbers. Then we loop from left to right and compare each pair of neighboring numbers. If the number on the right is smaller than the number on the left, we just swap them. Otherwise, we just leave them be. When we get to the end, we just go back to the start and do it again. We repeat this process over and over and over until we go all the way from left to right without making any swaps. Here's what it looks like on a larger data set.
Okay, down. Bubble sort repeatedly steps to a slice and compares adjacent elements, swapping them if they are out of order. It continues to loop over the slice until the whole list is completely sorted. Here's the pseudocode. Set swapping to true. What the fuck? Okay, swapping to true. Set end to the length of the input list. Okay. While swapping is true, set swapping to false. For I from the second element to end. For I from the second element to the end. If I minus one element greater than I. Damn, this is one of those other problems that I have to see. It's like one of yeah, it was like this binary search problem. It's like that. Thing is, we set swapping to true. Okay, let's look at that assignment. While our avocado toast influencers were happy to search functionality, sort all their followers by follower count. Bubble sort is a straightforward sort. So nums, let's see how it is. So nums is probably just some like 3, 16, 2, 5. You know what I mean? Like this, right? So what we need to do is check 5 to 7. If 5 is greater than 7, switch. If not, move on. Swapping to true. I just need a better explanation. on my own to learn. What is done before this sort compares each pair of adjacent elements in a list and then swaps up their order if it keeps them over. It says swapping to true. This is just a way to get the loop started. It's a flag that says I had to swap things last time. I might still need to swap more. Set end. This makes no sense. Bro, it's not the time, bro. Okay. Why? Because every full pass, the largest number bubbles up to the end. Hold up, guys. My bad, guys. Okay, set end to the length of the list. Swapping is true. While swapping is true. This is just a way to get the loop started. It flags that says I had to swap things last time. While swapping. So if this is, I think while swapping is true means that if the last time I swapped was like 5, 7, 3, 6, 8. I gotta look at this. How do I look at the next one? First one would be false. For I from the second element. Okay, while swapping is true. Damn, bro, this is fucked. So I'm gonna just tell ChatGPT, these are my thoughts. Let's see what it says. So one, it says swapping to true. So swapping is equal to true, and two, set end. So end is equal to the length of the list. Let's just say the list. So end is the length of the list, and then three. So I gotta do while swapping true. So while swapping is equal to true. And then if I do 4, we have to set swapping to false. So we gotta keep the loop running without needing to swap. This means the list is sorted. So you're hoping you won't need to swap anything this round. If a swap happens, you'll set this back to true. Set swapping to false. Okay. So set swapping false. You're hoping you need. If swap happens, you set back to true. So how was it structured? Set swapping false. Swapping is equal to false if I don't know. Swapping is false if nothing happened. Nothing happened. So 5 for each I. So for I in. So for I from the second element to the end. From the second element to the end. Second element for I in range the second element, so 1 to end if I minus 1 if I minus 1 if I minus 1 is the 1 minus 1 is element of the input list is greater than the greater than I. That's greater than I. Set swapping to true. Swapping is equal to true. Decrement n by 1. Increment, decrement, so minus. Decrement. So and minus equals 1. Swapping is true. Get started. This gets the loop going. Swapping equals true. I'm gonna be honest, guys. Off stream, I gotta figure out how to do this like 2-screen shit, man. I'm on Linux Mint, so it's like, fuck. No, it's just annoying. Whatever. I hate going back and forth. So we have to say swapping to true. So end is equal to the length of nums, which nums is our list. And I said while swapping, yeah, okay, so while swapping is equal to true. So swapping is equal to true. No, we're not gonna use our root. It's nums for sure. You wrote swapping to false if nothing happened. Correction, you want to set swapping equal to false at the start of each loop before the for loop. This way, if no swaps happen during the pass, it stays false. Okay, so made a mistake here. I'm supposed to put this. So we'll say swapping is equal to false. Sorry, I can't spell. So swapping is equal to for. This has to be right. Yeah, for iron. Yeah, this is right. I know it. So for iron range 1 to n. So that's the second element. Yeah, second element to the n. We want to do if I minus 1. See, I minus 1 is it greater? No, I minus 1. Swap out. If I minus 1, the element of the input is greater, so if this is greater than I, what we're gonna do is swap. Okay, swap, I don't know how to do that. So then that means I is I minus. If I minus 1 is not the right comparison, instead you want to compare the values. Oh, right, so this is just giving you the index, dumbass. So we want to do this. We want to do this. And we want to do numbers. This. Boom. Now we want to swap these. So how do I set? Okay. Swapping equals true. So we're gonna say then we're gonna set swapping equal to true. Swapping equals true. Decrement end. So we want to do end minus equals 1, and then we can return shit out. This is what I have so far. I have an issue. Don't give me the code I would like to do on my own. Just hints. What are you returning? Ask yourself, are you supposed to return and or are you supposed to return a sorted list? I'm supposed to return a sorted list. Why the fuck am I returning in? I return swapping. Swapping is just gonna return true or false. Yeah. True or false. Should I have appended? If set swap equals true and check if swap is needed. But are you actually doing a swap when think about bubbles where actually means bigger numbers bubble up because we swap. You loop into the numbers and check final. Think of what has to change the size of the loop to physically move values around. It says swapping is true. How do we swap it? Well, that's why so far range if nums I range is greater than the nums I. If nums I is minus the first one. Is greater than I. We say swapping is true. Swapping is true, and now we need to actually swap it. How do you swap indexes in Python? One, 4, 3, 2, 5. I think I know. So now we're gonna do. I think okay. So index 1 is 1. Index 2 is 3. So my list. So we have to get nums. So now nums. I minus 1. I minus 1 is 4, 2. So my next one is 1. So if I do my list index 1, it's gonna be 2. Oh, and he swapped it. get it. Oh, swapping. Yeah, you don't even need that. Okay. This is already true. Swapping is close for iron range 1 to n. If nums I minus 1 is greater than nums I temporary equals nums. So nums I minus 1. Some of these looks a little bit confusing. I get this one though. These just switch here. N minus 1. Dang. I get it. I get it, boys. I get it. I gotta start understanding that this right here, index, will call the actual value in the index, and it's very important. I always forget this. It's a problem with me. But hey, we writing it down was very helpful with the pseudocode and trying to actually like solve it. But alright, let's do these, and then what is Bulbasaur's big old complexity? So Bulbasaur information reference, right? What we just did. Sometimes it's useful to know how the algorithm will perform based on what input data is, instead of just how much data there is. Best case is the data is pre-sorted. Bulbasaur becomes really fast. Can you see why? The data is reverse ordered. Bulbasaur becomes really slow, but it's still. That was constant, because it's constantly like it's like constant. I don't know. And it's squared. It gotta be. I don't think it's this, because this is the fastest. Explain that shit. Okay. What is the best and worst case run jobs? At best and square. That's why I said O of n, because it could be like constant, because it's already sorted, but I see what they mean. What is a good reason to use Bulbasaur? Because I'm studying algorithms, so I don't even need to read that. Alright, cool. So we'll save merge sort for tomorrow. I think maybe we should try. Is there any algorithm? No, is there any? Okay, let's see what this is. Is there any lead code style questions I can solve on my own? Now that I learned bubble sort to better my knowledge. Sort colors equals asymptotic. You are given an array nums and objects color red, white, or blue, where 0 represents red, 1 represents white, 2 represents blue. You must sort them in place so the objects in singular. Good problem. 2 0 2 1 1 0, so 0 0 1 1 2 2. That's a good problem. I'll try this on my own. I will try this on the next video and then move on, so we can learn. But yeah, guys, long video, I guess. I'm very tired. Yeah, I got some work to do later, so that'll be today's video. Thank you for supporting, and I'll see you guys tomorrow, which will be 2 weeks, 2 solid weeks grinding. So yeah, if you guys have any anything to say, just put them in the comments. I'll respond. So thank you guys for staying this long.